Welcome back to the Intelligent Founder AI podcast. Today we're leaving per-token pricing behind and stepping into the world of rented GPUs, the neoclouds, the marketplaces, and the new compute arbitrage that most founders are ignoring.
If episode 2 was about the world of pay-per-token, this episode is about the world of pay-per-hour. GPU rental markets have gone from a niche offering that only a few well-funded research teams use to a multi-billion-dollar industry in the space of 3 years. And for founders at a certain scale, they represent a genuinely compelling alternative to both hosted APIs and owned hardware. Let me set the scene first, because the scale of this market matters for understanding the dynamics. The global GPU rental market expanded from $3.2 billion in 2023 to a projected $9.8 billion by 2025, with continued strong growth expected through the rest of the decade. That growth has been driven by two things happening simultaneously: the explosion in demand for AI compute from every direction, and the entry of specialist providers who are not the large cloud platforms, who specifically built for the AI workload and for the startup and research market, Spheron. These specialist providers are what the industry calls neoclouds. The name is useful because it distinguishes them from the hyperscalers. CoreWeave, Lambda Labs, Crusoe, RunPod, Spheron, and a growing list of others have built GPU-first infrastructure businesses that compete directly with AWS, Google Cloud, and Azure on price, on specialization, and increasingly on developer experience. CoreWeave is the largest of these, with trailing revenues of around $3.5 billion as of mid-2025 and a successful IPO in 2025. Lambda Labs sits at around $500 million in annualized revenue. These are not small players. They are serious infrastructure companies that have built their entire business model around serving AI workloads. Sacra. What makes neoclouds genuinely interesting for founders at the right scale is price. H100 class cloud rental in the 2026 runs somewhere between $1.80 and $3.50 per hour on specialist providers. That compares to significantly higher rates on the hyperscalers, where the same hardware often costs $3 to $5 per hour or more, depending on region and commitment level. Spot pricing on marketplace platforms can go as low as $1.20 per hour. AMD MI300X and consumer-grade RTX alternatives often come in 30 to 40% cheaper than Nvidia H100 for equivalent inference throughput on many model types. Presence plus one. The difference between the neocloud providers is not just price. CoreWeave is oriented toward enterprise scale. Long-term contracts, large commitments, and whole facility deployments for the largest AI companies. Lambda Labs has built its reputation on developer experience and flexible access, making it practical for a 10-person startup to rent a few H100s without signing a multi-year commitment. Crusoe differentiates on its energy source, specifically using gas that would otherwise be flared at oil extraction sites, which gives it a sustainability story and lower power costs. RunPod and Vast.ai operate marketplace models that aggregate GPU supply from many third-party sources, often producing the lowest available prices, but with more variable reliability and less enterprise-grade SLA coverage. Matrix BCG+2. Choosing between these providers is not just a price comparison, it is a question of what your workload needs. Training runs that can tolerate interruption and do not need 99.9% uptime can use the cheapest marketplace options. Production inference serving real users needs reliability, consistent latency, and proper SLA coverage. The provider you use for experimentation may not be the provider you use for production, and that is fine. Keeping separate providers for different workload types is completely reasonable architecture. Now let me explain the 4 pricing models available to you, because understanding these is essential for managing your actual cost. On-demand is the simplest. You pay by the hour, you start instances when you need them, you shut them down when you do not. The price is the highest of the 4 models, but you carry no commitment risk. This is the right choice for variable or uncertain workloads, for experiments, for development, and for any situation where you genuinely do not know how much compute you will need next month. Reserved instances are paid in advance for a committed period, typically 1, 3, or 6 months, and they typically offer 30 to 60% discounts over on-demand rates. The risk is that you are committing to pay for capacity whether or not you use it. The benefit is that the savings are substantial for any workload you are confident will run consistently. If your production inference traffic has been stable for at least 2 months, and you can forecast it with reasonable confidence for the next 3 months, reserved instances are almost always the right choice. Crusoe compute. Spot or preemptible instances are the cheapest available pricing. They operate on the principle that the provider can reclaim the hardware with short notice, typically a few minutes, when demand from on-demand or reserved customers increases. This makes them completely unsuitable for production inference where interruption would affect users. But for training jobs, for data processing pipelines, and for any batch workload where you can checkpoint your progress and resume from where you left off, spot instances are an excellent cost tool. Some training workloads run entirely on spot instances and save 60 to 70% compared to on-demand. Crusoe compute. Bare metal access is the fourth model, and it is for teams operating at significant scale. Bare metal gives you direct access to the physical server without any virtualization layer. This eliminates the overhead of hypervisors and VM management, which for GPU-intensive inference workloads can represent 5 to 15% of compute efficiency. If you are running GPU clusters at high utilization and you have the infrastructure engineering capability to manage bare metal deployments, this additional efficiency can be meaningful at scale. Crusoe compute. Let me give you a practical break-even calculation so you have a concrete number to work with. At 24/7 usage, a single H100 GPU at $2.50 per hour costs roughly $1,800 per month. An 8 GPU node running continuously runs around $14,000 to $16,000 per month, depending on the provider and configuration. If your inference workload is saturating that GPU at 40 to 50% utilization, meaning the GPU is actively processing tokens roughly half the time, you are approaching the threshold where buying hardware starts to be worth evaluating. Above 60% sustained utilization over a 3-month period, the economics decisively favor owned hardware, and we will go through exactly that maths in the next episode. Factory app plus 3. There is a hidden cost in GPU rental markets that most cost comparisons completely ignore, and that is egress. Moving data out of a cloud environment costs money. The typical rate across providers is between $80 and $90 per terabyte of outbound data transfer. For applications that involve large input documents, large generated outputs, or model checkpoint files that need to move between environments, egress costs can add 20 to 40% to the apparent cost of your GPU rental. This is not a niche concern. It affects any application that works with large documents, media files, or models over 10 or 15 gigabytes. Include egress in every cost calculation you do, because it almost never appears in the headline pricing that providers advertise the code brew tools. There is also a significant engineering cost that is easy to miss when you look at GPU rental pricing on paper. Running inference on a single H100 is reasonably straightforward. There are good model-serving frameworks, VLLM, TGI, Tensor, RTLLM, that handle batching, quantization, and continuous batching for you. But running inference efficiently across 8 or 32 GPUs requires tensor parallelism, pipeline parallelism, or both, depending on your model size and your throughput requirements. Getting this right is non-trivial engineering. Most startups that move to multi-GPU rental setups underestimate how much work is required to actually saturate the hardware. If your team does not have deep ML infrastructure experience, you will pay for GPU capacity that you are not effectively using, which drives your effective cost per token significantly above what the headline rental rate implies. This is one of the reasons the API to rental transition needs to be timed correctly. You need to have your production observability in place, your utilization patterns clearly understood, and your infrastructure engineering capability ready before you make the move. Moving too early means paying for GPU capacity you cannot saturate. Moving too late means leaving significant margin savings on the table. The strategic use of GPU rental markets for most founders at the Series A to Series B stage is as a bridge layer, not a permanent destination, but a stepping stone between pure API dependence and owned hardware. You use rental to test your model deployment, to validate your serving architecture, to measure your actual utilization patterns under real production load, and to accumulate the operational knowledge you will need before committing capital to owned hardware. The staircase is API first, GPU rental second, owned hardware third. You move up each step only when the data from the previous step justifies it. For the cost calculator, the GPU rental tab should capture your model size in billions of parameters, your required tokens per second throughput, the GPU type you are targeting, your pricing tier, your egress volume per month, and your expected utilization rate. The output should be a monthly effective cost per million tokens, directly comparable to the API scenario you calculated in the previous episode. Running these two numbers side by side is how you make the migration decision with evidence rather than intuition. Thanks for listening to the Intelligent Founder AI podcast. If this episode changed how you think about CoreWeave, Lambda, or any GPU marketplace, forward it to a founder friend who's still living on on-demand instances.